All right, welcome to today's notes. The title of today's notes will be the real number system. If you could go ahead and draw this diagram. Let me make it a little bigger. Okay, if you could go ahead and draw that diagram at the top of your notes, and then we're going to go through and define those 6 terms. I'll give you some examples of each. Okay, so you might need to pause throughout so you can draw things or write down definitions because I'm going to go pretty fast. Okay, we're going to start with natural numbers, the most specific of the rational numbers. Okay, and those are all the counting numbers, 1, 2, 3, 4, 5, 6, any numbers that you learned when you were 2 years old. Okay, we look back at our diagram, kind of see where natural numbers is. So you might want to even go back and write in your diagram, you know, the number 1, the number 2, just some examples. Whole numbers are all those counting numbers, but 0 is also included. So it's really just the natural numbers plus 0. So if you want to add 0 as an example in your diagram, that would be good. Okay, so we've got natural, then whole, and then integers. Okay, so integers are all the whole numbers plus their opposites. So 1, 2, 3, 4, 5, 6, all those numbers are all integers, but then -1, -2, -3, -4, all the way to negative infinity are also integers. A lot of times I hear students say it's a negative number, it's an integer, but positive numbers are also integers. Okay, and decimals are not included in the integers. It's the whole numbers and the opposite of whole numbers. Okay, next up we have rational numbers. So all those natural, whole, and integer, they're all rational, but then there's also some other numbers that are rational. And that's any number that can be written as a fraction. Okay, a over b, where a and b are both integers. B cannot be equal to 0, which I know we've talked about in this class. So any integers, terminating decimals, and repeating decimals that we've talked about, because they can all be written as fractions. We know how to turn a terminating decimal into a fraction. We talked about that, and we know how to do the repeating decimal. That was that long process with making the equations. So those are why those are all rational. If you can write it as a fraction, it's rational. So then there's only the one other set of numbers, which is irrational numbers. And those numbers cannot be written as a fraction. Okay, so pi goes on forever. It cannot be written as a fraction. Any multiples of pi, 3 pi, 4 pi, and any decimal that goes on forever without repeating. So if it goes on forever, it doesn't repeat. That makes it irrational. Some other examples are square roots of numbers that are not perfect squares, like the square root of 2, or the square root of 3, or the square root of 5. Those are irrational. If I were to put them into a calculator, I get a decimal that really goes on forever. It would stop it, but it doesn't actually stop. It goes on forever. It doesn't repeat, does not terminate. Okay, and last is the real numbers. So real numbers are all the rational and irrational numbers. Okay, all numbers that you know are real. So there are some imaginary numbers that you learn about in high school, but we don't need to worry about that. If you want, I can tell you some in class, but all real numbers are rational and irrational. All right. So the only other thing I might say is for it to be helpful, I might go through and jot some numbers into those boxes. Let me see if I can do it now with this. Oops, maybe not. Okay. Yep, I put 1 and 2 in there. 0 would go under whole. These are all integers too, but then I might include -1, -2, and on to negative infinity. And rational, 1/5, 0.3, repeating, point, that's a terrible 0, sorry, but I'm running out of time. I've only got 15 seconds. Irrational number, square root of 5, pi, and my screencast is about to end because I'm only allowed 5 minutes. So that is it for the notes today. Hopefully you got that all down. Thank you.